Yes, sir.
I changed the values and given not to complete the task. Have you completed the problem? Have we completed or not? Completed or not? The hands up for the same.
Yes, sir.
No. Why one day Sunday is not enough to complete? It's just take 5 minutes. I'll if you try to complete right now, I will give 5 minutes time.
Sir, completed. Just wait a minute.
Okay, post it in the chat box. And your name?
Sir, Benjamin, I already completed. I am searching for my notes.
Okay. What about remaining? Remaining all? Guys, remaining guys, try to solve now itself. Just take 5 minutes, not more than that. Just simple. Directly you're going to apply the into the formula and you're going to get the value. Benjamin, have you got the notes?
Yes, sir. Only that.
Yeah.
Value of I equal to 6.25, sir.
I can get you. Hello? I didn't get you, ma.
Yes, sir.
You just take a snapshot and put it in chat box. Is it possible for you?
Sir, actually, sir, நான் ரொம்ப கச்சா உச்சான்னு எழுதி வச்சிருக்கேன் சார்.
No problem. You try it and at least just put it. It's not an issue.
Okay, sir.
sir.
Yeah.
Sir, posted.
Sir, calcs
Okay.
மாத்திருந்தீங்களா sir? Did you say they changed? Which you have changed?
What happened?
I didn't get what you are saying.
Okay, okay. So the V is 20. I will share it.
Okay, sir.
R1 25, sir. R2 20, R3 50, R400, sir.
Sir, I posted in chat. Chat box.
Yeah, yeah, yeah.
Sir,
Yes, yes, yes. I got it. I got it. I think everyone will see that one.
the 1 minute.
Can anyone can able to see?
Yeah.
All of you can able to see, right? My screen.
Yes, sir.
Yes, sir.
Yes,
Yes,
sir.
sir.
Yes, sir.
Yeah. So V is equal to 20 and R1 25, R2 20, R3 50,
Is equal to
R4
20.
400. Okay. So directly you are applying using the Ohm's law. So I want to identify what is the I1, and we know that in parallel the voltage is common. So I'm using to calculate the I1, I2, I3, I4 with same voltage level 20 only. Okay. And in order to find the particular current, I am dividing by the R1 not to find the I1. So that 20 divided by 25, you got 4 by 5.
0.8
And
amps, I1.
how much?
0.8 amperes, sir.
0.8 ampere, 800
8,
milliamps, right?
yes, sir.
800 milliamps, yeah, we can tell like that also. Not issue. Everything is correct only. And second one is 2020. You got 1 amps. 20, not 1 amp. This is everything is ohm, not in K. Just 25
Yes, sir.
ohm, 20 ohm. Okay,
Yes,
then
sir.
you
Ohms
got
only,
1
sir.
amp. Then 1 amps current is I2. And if you come to
I3,
I3,
2.4 amperes, sir.
okay. And what about I4?
0.05 amperes, sir.
0.50 milliamps. Or because here I'm using 400. So while you increasing the resistance, the current is get decreases. Okay, only 50 milliamps I'm getting. And the total current is how much I got?
2.25. Down, sir.
2.25 amps. So 2.25 amps.
Can you raise the screen, sir, for no, an I4, sir?
I4 here 1 by
Okay,
20.
sir. Yes, sir.
Okay, very good, Benjamin. At least you did this. It's
Totally
look good only.
2.25 amperes, sir. Current.
Yeah. So don't forget to put the unit. That is my important one. Okay, 2.25 amps. Then only
Yes,
you will
sir.
get full marks in everywhere. Even you while mentioning the I1, I2, I3, I4, you have to put the amps unit, 1 amps, and like that. Okay. So then you will get full marks without any doubt.
Okay.
Like 5 members are coming to college very late. Okay, so we will start the today class. What about the remaining guys? If you completed, put it in chat box. Remaining guys, if you completed, you just take a pic and then post it in chat box. Okay, and we will go to the next topic. So Kirchhoff laws. So there are two kind of laws are available now to do the analysis purpose. One is the Kirchhoff current law, and second one is Kirchhoff voltage law. So first one, we are going to look at the first law, Kirchhoff current law, or it is also called as the point law. This is you can able to read this sentence, or I want to zoom it.
So you can read it, sir.
Read
Okay,
it,
okay,
sir.
okay. So the first law is nothing but the algebraic sum of currents meeting at a point or a junction in an electric circuit is zero. Okay. So for example, I will draw. You know that this is just a basic circuit. I'm going to draw here. This is a voltage source V, and I'm going to connect here one resistor and here one more resistor. I'm just connecting two resistor here, and you know that from here the total current I will flow, and here I1, I will represent I1, and here is I2, and here it is IT. What the law is telling is, you take this junction, this is just take a node A, okay, at a node A, okay, if you do the summation of the incoming current and outgoing current, then your value should be equal to your zero. So how much current is coming, okay, so that will be divided into two. You know that if I total is coming, and based upon the resistance value, the I1 will get divided and I2 will get divided. If it is, if you are using same resistance value, it will divide equally. If you are using different resistance, it may vary based upon the resistance value. If resistance is higher, the current will decrease. Now the point is, how much current is coming in this way, the same current will leave the node, okay. So I'm going to take a incoming current as a positive and outgoing current as a negative. Why? Because it is leaving away from the junction, okay. So if you did the total summation of the IT and along with I1 and I2, then your sum will be equal or not? I mean, sorry, your final value should be equal or not? It will be equal only, right? So how much, for example, I'm getting a 5 milliamps. IT is 5 milliamps. IT is 5 milliamps. Wait a second. IT is 5 milliamps. And your I1 is, let's take 3 milliamps. And your I2 is, how will it be? How much I2 will be?
2 milliamps.
It will be 2 milliamps, right? Okay. So the remaining current will flow through I2. Okay, so this is 2 milliamps. Now,
Milliamps.
yeah, IT is coming towards the junction. So I will consider IT total current as positive. Okay, so I will mention here symbol a positive. And I1 and I2 are leaving away from the junction. So I will consider it as negative. Why? Because it is moving in another direction. Now, if you did the sum of everything, what will be your resultant value? What will be your resultant value? So plus 5
It will be
minus
0,
3
sir.
minus 2. It will be equal to 0. That is your
0.
first law. So that will be your first law. Okay. So just consider here, they are showing one node. Yeah. So here, this is nothing but your junction or node, whatever you can call. Okay. And here, how many currents are coming in inside towards the junction? So I1 is coming,
3.
and I2 is coming, and I3 is coming. Totally 3 currents are coming towards the junction. So they are represented using the color variation. So it is represented using a blue color, and the 2 currents are going away from the node. So that is nothing but I5 and I4. So you know the concept. How much current is coming, that will be surely the every current will leave. So if you do the addition, I mean summation of every current which is coming towards the junction and moving outwards the junction, then your resultant will be equal to your 0. Okay. So that is what here they represent. I1, I2, I3 are in addition, and they are in positive. Why? Because it is coming towards junction, and I4 and I5 are moving outwards the junction. So you can substitute the value as 0. So here again they given the statement, same statement. The sum of the currents flowing towards any junction in an electric circuit is equal to the sum of the current flowing away from the junction. How much current is coming inside, the same amount of current will leave it outside, like a pipe and water only. So if you connect the single pipe coming in one direction, a single pipe is coming in one direction, and I connected two connected here. So how much water is coming, the same amount of current water will flow in both the direction, right? So this is the total volume of water that will be divided based upon the size of your pipe. Similarly here, this resembles the current is nothing but the water, okay, and the size of your pipe is represent your the resistance value. Okay, likewise you can assume it. And second law, so there is a second law is there, and all of you following the notes, right, guys?
Yes, sir.
Yeah, just take down the
Yes, sir.
take down the stop and then write the first law and the definition. Just take down it. No?
You have already given the PDF, sir.
So you are using that one.
Yes, sir. We are taking printout of PDF and following.
Taking printout of PDF immediately. Wow, great. While listening that, but practice
Thank you,
give
sir.
more experience so that you won't forget in your life. Okay, anyway,
Right.
come to the second law. So Kirchhoff voltage law. So previously we seen about the current, and now we are going to see about the voltage. Okay, and here you know that in a circuit there will
Sir,
be a
இல்லைனா சார் 1 minute மேலே எடுத்துன்னு போங்க சார். நீங்க போட்ட சர்க்யூட் டயக்ராம் அந்த சம் ட்ரா பண்ணிக்கிறேன்.
this one.
Not this one, sir. Up one, sir. That
This
diagram
one.
we draw, yes, sir. Circuit diagram.
Okay, that is for example for your understanding purpose. Okay, okay. That diagram is not good.
பரவாயில்ல சார்.
This writing in mouse. This amount.
சார் நீங்க காலேஜ் கிட்ட இருக்கீங்களா சார்?
Yeah, inside the college campus.
Oh, you are inside the college. Staying inside itself, sir, in hostel?
Outside.
Outside. Where, sir?
Have you completed this?
Nah, drawing and simultaneously talking.
It's not advisable to talk. If you're having any doubts, you can. It's a class. It's not a personal chat to talk. Okay. Many times I'm telling the situation, you people are not understanding.
Copy, sir. நான் பண்ணிட்டேன், மத்தவங்கள பத்தி தெரியல சார்.
Okay. And completed. Have you? Everyone?
Yes, sir. Yes, sir.
Sure. So next is voltage law. Okay. So I'm going to draw the same diagram with. So current law means it will be in parallel. Then only current will divide. But here the voltage law, right? So the voltage law is applicable if the components are connected in series maximum. Okay. Everything is parallel means then the voltage is common, right? So something should be in series. So this is two resistor connected. Okay, so for an example, so how much voltage I am providing, suppose I am providing the 10 volt here, that 10 volt will divide. So 10 volt will be, I mean the voltage drop will occur at each and every resistance. If you do the summation of this will be equal to your 10. That you know this concept, right? The voltage drop.
Sir?
Hello?
Sir,
Yeah?
it seems some students are not able to enter the class as usual. Swapnil, Moore, and Sabrinathan. Yes, sir. They are outside the lobby, sir.
Overall, Rafil is there.
Swapnil, Santosh, Moore, sir, and Sabrinathan.
Sabrinathan is already available inside.
Sabri Vantiada. Okay, sir. He informed for 2 minutes, sir. Sir, another person, Swapnil Moore, sir.
Not available.
Sir, it seems even Rafil, sir. Sir,
Rafil, Rafil is inside.
Rafil came,
It's showing like available.
Swapnil Moore also, sir.
Swapnil, Mare. Yeah, he is available inside. Just look it.
Sir, but
Look
no,
the
sir. How it
participant.
is means they are inside, sir. உங்களுக்கு உள்ள இருக்கிற மாதிரி காமிக்குது. But அவங்க ஸ்கிரீன்ல வந்து அவங்க உள்ள வராத மாதிரி காமிக்குது, sir. ask them to talk sir. Rafil கேக்குதாடா சொல்றது? See sir, அவங்களுக்கு வந்து உங்களுக்கு இருக்கிற மாதிரி காமிக்குது, but for them it is showing that they are not allowed to enter class. Like that only it is showing for them.
Oh, maybe network issue or I don't know what is the problem.
சார் ப்ராப்ளமே அட்டெண்டன்ஸ் கூட விழ மாட்டேங்குது சார். ஆனா உங்களுக்கு இல்லாத
Ask them to try it again.
1 minute sir.
Otherwise, guys, I put this link in the group so that they can join.
Swapnil bro, can you hear what I'm saying bro? Swapnil.
Sometimes the people will available but not physically.
No sir, they are texting in WhatsApp sir. Let me even share you the screen sir. They are saying that enala varamula enala varam like that saying sir. They are available only.
Okay, I will remove him from meeting. Again, I will invite him.
Okay sir, okay sir.
Swapnil.
Remove these 3 people sir. Swapnil, Rafil and Sabrinathan sir.
Rafil just now I admitted. Okay. And Sabrinathan. Just send the invitation. I think now he joined. Swapnil? Yeah, I can hear you. I can hear you. What about Sabri? Are you there? Sabrinathan?
Okay, sir.
Okay. What happened?
Rafil,
Sir, am I
I
audible,
invited.
sir?
Yeah.
I
Audible.
invited now. Okay. Yes,
Yeah,
sir.
now only sir all this enter.
Okay.
Okay sir. Carry on sir.
Okay. 2 people. Okay. Shivam, good to see this. You have posted the task. I'm expecting from remaining students also to post there. Okay. Let's see after the end of the class.
லேட்டா போஸ்ட் பண்ணா காப்பி பண்ணி நினைச்சிருந்தா போஸ்ட் பண்ணல பண்ணிட்டா.
It's not an issue. It's not an issue.
Okay.
Okay. You can post at the end of the class also. Not an issue.
Okay sir. I have already copied sir, but I didn't do it on my own. I just copied what you said. That time
Okay. Can you able to see the screen right now, the book?
Yeah sir. Second.
Yes, sir.
First law.
Yeah.
Second law.
So now we are going to see the second law, Kirchoff voltage law. So here, what are the voltage is dropping? That will be equal to your supplying voltage. That is a common, right? You know that. How much voltage is dropped? That will be. I think someone have making too much noise. Mukhtar, Omar Mukhtar, just
Yeah
mute your
sir.
mic. Yeah, mute your mic. I'm
Wait.
getting a lot of noise. What is this? Is this Omar or?
So
I'm
it is
getting
from
noise.
Swapnil, sir.
Some just all of you mute your mic. Well, if you want to talk on the time, unmute it. Everyone, mute your mic.
It is from Swapnil sir. Swapnil Santosh. என்ன போய் சந்தேகப்பட்டீங்களா
Yeah.
சார்?
Okay. But it is not showing in the display. That's why. Okay, come back to the class. Here, how much voltage is dropping? That if you do the addition, I mean summation of each and every voltage drop occurring at each and every component, that will be equal to your the voltage which you are providing. Okay, so just look at the statement right now. In any closed circuit or a mesh, okay, closed circuit or a mesh means having a lot of loops. Okay, so this is one loop. If you look at this diagram, can you able to see that what I'm drawing? So this is considered as a one loop. Okay, if you're having more number of then it is called as a mesh. Okay, in a closed circuits or a mesh, the algebraic sum of all the electromotive force and the voltage drop is equal to 0. Okay, so all the electromotive force representing the voltage source. Here the electromotive force representing the voltage source V, and the voltage drop is voltage drop representing the voltage occurring each and every component. So you know that how many resistors you are using, that much voltage drop will occur. If you do the addition of that one along with the electromotive force, then it will be equal to your 0. And in this case, I am considering electromotive force as a positive and remaining the voltage drop as considering as a negative. Why? Because it is drawing the power, it drawing the voltage from the voltage source only, and the voltage source is used to deliver the power. Okay, so we used to tell power actually. It is not the voltage source not only delivering the voltage as well as the current. So current and voltage combination, we used to tell it as a power. In your home also, if the light goes off, means you should mention power gone, not a current gone or not. Okay, but usually many homes they will tell current gone likewise. So you have to, as a electrical students, you have, sorry, you are not electrical students, right? Sorry. So anyway, as a technical person, you have to tell the power goes off. Okay. Okay, guys.
இது கூட பரவாயில்ல சார், சிக்னல் இல்லங்கறத டவர் இல்லன்னு சொல்றாங்க சார்.
Yeah. Okay. Yeah, you have to change the world because you are an engineer. So this is the second law. So this law we will use in order to find the voltage drop occurring at each and every component. In previous case, it will be used to find the current. Based upon the current, I can able to analyze the circuit, and here I'm going to analyze the circuit using the voltage law. And so here they given such that the algebraic sum of the EMF representing the electromotive force, it is nothing but the voltage source. In your circuit, you are not going to use only one voltage source. It may be multiple voltage source. Addition to that, algebraic sum of voltage drops. So voltage drop representing drop occurring at each and every component. If you do the addition, it will become 0. Okay. And look at the circuit here. They given on circuit having the node A, B, C, D, and E, and we having many things: V1, V2, V5, V4, V6, V3. Here we don't know what are the things are voltage source and what are the things are component. Just generally they are given. Okay, look at that sign here. It is starting with positive and negative, and here it is starting with negative to positive. Okay, for example, guys, I can consider here 3 loops. So what are the loops means? I will consider A, B, D, sorry, A, B, E, D. So I will draw a, from here I will make this as a one loop. Okay, loop 1.
VEC கூட ஒரு லூப் சார், அதுக்கப்புறம் AD ஃபுல்லா கூட ஒரு லூப் ஆகும்.
VCE is another loop, and I will take the entire circuit as a one loop from here to here. So totally 3 loops is there. Okay, this is loop 1 and this is loop 2, and the big one, the entire is considered as loop 3. Okay, so if you are considering the loop 1, so I will start with A and I will flow to B, and from B to E I will go, and E to D I will go again, D to A I will complete one complete loop. Okay, I want to do the analysis in this. If I'm going in this way, look at that, from A to B I'm going to cross the voltage with positive to negative. Okay, and look at the B to E, whether it is in opposite sign, right? So I'm going to cross from minus to plus, and look at the E to D, this is also minus to plus, and D to A also it is minus to plus. So if I'm considering V1 as positive, and I am taking the value from positive to negative, so that I will consider V1 as a positive, means then if the V4 is going minus to plus, so that I will consider this in opposite sign, so I will consider it as negative V4. And then if you look at that from E to D, whether I want to mention this positive or negative with respect to V1. With respect to V1, so I will consider as a negative V6. And then what about the next one, V3?
Same.
Minus
Negative.
V3, negative. Suppose if you are considering V1 as a negative, means I will totally change. This is nothing but minus V1, and the V4 should represent in opposite polarity. So So V4, and similarly plus V6 plus V3. So simply you can change the sign to everything based upon our convenient. Okay, in the first equation I represent V as a positive, so remaining will be negative. In second case V1 is negative, means the remaining should be in positive. Why? Because it is changing the sign. So simply if I add minus to everything, it will change
Sir, if
to
V1 is
second
coming
equation.
ulta over the sir, if it is coming from V1 to V3, then what will be? So it will be again negative only, no, sir?
Which one? No, look at this.
If
V1 is going in path. So this is from positive to negative. So I will consider any one sign, whether you are going to consider it as a positive or negative. Which one?
if I'm considering it as positive, sir, then it will be
Okay, okay. Then V1 is positive. Okay, next you go to V4. It is going from minus to plus. Similarly, V6 also minus to plus, and V3 also minus to plus, right?
yes, sir.
And so remaining all should be in same polarity. So if this is considered as negative, means everything should be in minus. Okay, likewise I will mention. And if you look at the second loop, go to the second loop. So can anyone tell the equation for second loop L2?
Minus V2
Minus V2
plus
Plus
V4
V5,
plus V5
V5,
plus V4.
V4 minus
and
plus V4
Minus
Sir,
V4, sir.
plus.
Minus V4.
Yes.
plus sir, there is any something missing, sir. There is no voltage there, sir, in direction.
No, actually, this is
Circuit
the
அவ்வளவுதானா?
same thing you will take here. Okay, so here itself, they mentioned it is common to loop 1 and loop 4, loop 2, right? V4 is common to loop 1 and loop 2. Okay, so while considering this should be, you have to mention like this. And if you look at that better, I will type it now. Yeah. And what about L3, loop 3?
If it is passing from V1 now, sir, V1 will be positive, sir. Sorry, V1 will be negative, sir.
So V1 negative, so minus
Yes, sir.
V1,
It will be
and
going to
then
V2, sir, plus positive V2, sir.
so plus V2,
Next to V5 positive, sir. After that, V6 positive, V3 positive, sir.
so V1 negative, V2 is positive, V5 is, it is loop 3.
V5 will
Negative.
be yes, positive.
Negative.
It's been
Positive, sir.
negative,
V5.
minus V5. Just V5
yes,
symbol is equal to your V1, right? Okay, and then
plus V6
V6 is plus V6.
V6 is an yes, sir,
V6
positive.
plus V
Next to V3 also positive only, sir.
and V3 is plus V6. So this
V3
equation, sorry,
two
V3,
times
yeah. So V3 is equal to 0. I can make it each and every equation is equal to 0. So this is the thing. Okay. So look at the first equation which I written, that is represented here. So V1 is positive, means remaining all should be negative. That will be equal to your 0. And
Sir,
applying
once
the
again கொஞ்சம் மேல
Kirchhoff
போயிட்டு அந்த
voltage.
loop 3 மட்டும் காமிக்க முடியுமா, sir?
Yeah.
Loop 3. Okay, sir. Thank you, sir.
Okay. So you have to equate each and every equation equal to 0. Then you can able to do the analysis purpose. We will do this analysis in the example. Okay. So look at this. Here they are applying the loop. They represent the loop node. Instead of that, I represent it is nothing but loop 1. Okay. So you got the value as V1 is equal to, sorry, V1 minus V4 minus V6 minus V3 is equal to 0. Okay. If equal to 0, I can change the sign, right? If I apply negative, then your equation will become like this, minus V1, and remaining all will become plus.
Positive.
So yeah, it will become like this, plus V6 plus V3 is equal to 0. Why? Because it is equal to 0. So I can change the sign based upon our convenience. If you look at this statement here, so V1 is giving the supply and V4, V6, V3 are consuming that supply. So V1 is represented as voltage source and the remaining are the component which is having the drop. Similarly, here also you can consider likewise here. So in this case, see, look at that V1 is negative. So that I will substitute minus negative to all. So V1 become positive, remaining all become negative. So in this case, I will consider V1 as a voltage source similar to the first equation, and remaining all is nothing but having the voltage drop across the each and every component. Okay. Similarly in last case. So one, okay, they are rearranging the equation. Okay. So it is nothing but they applied the negative signature. And similarly, this is, I think, loop 2 equation, and the last one is, this is loop 3 equation. Okay, guys. So do you want to copy everything, anything? At least write the statement in your note. Write the statement, the first last statement and second last
Yes,
statement.
sir.
Yeah, write the statement. If you completed,
Yes, sir.
1 second, sir. Wait. Okay, sir. Complete, sir.
okay. This is just a kind of a problem. So draw this diagram. Draw this diagram.
நாளைக்கு போடுறதா சார்?
No, now itself.
Sir, today we have 3 periods, sir. உங்களது back to back.
What theory is only one.
ஓ, அந்த 2 கிளாஸ்ல நீங்க practical சொல்லி தருவீங்களா சார்?
Okay, I will do classes out
சார்
there.
இருக்கட்டும் சார். Can go for practical.
Okay. So theory maximum, I will take the theory classes in theory period, and lab hours we will do the laboratory. And today we want to do the practice session, and one period you have to write the manual. So observation you have to write, and second period we will do the simulation purpose.
Okay.
So while coming to the afternoon classes, so be ready with a fresh note. So while coming to the college, while doing the practical examination, you have to bring that observation. I will evaluate it and provide the marks.
Same copy
Observation
you have to bring,
consists of
sir.
yeah,
எங்கிட்ட நோட் இல்லை சார், முதல்ல சொல்லுங்க.
just an observation, and later you have to write the record. So first observation is mandatory in the laboratory classes.
Last Saturday we came to college, sir. அதான் சார் கேட்டேன். You are in college or near college?
Okay. Completed.
Yes, sir.
I
Yes, sir.
completed
Completed, sir.
for about a year.
Check it. So here, this is the voltage source, 28 volt. Okay. 28 volt. So just consider this as a positive and negative. Okay. And here it is the voltage drop will occur, so that I will consider from here as a positive and negative, so that the sign will vary, right? From here only it will consume R1, and similarly here also I will consider the same flow, plus minus. Okay. And now you want to write the loop equation. This is nothing but I1. Okay. So how you will write the equation according to the KVL, Kirchoff voltage law? How will you write? First tell, later we will write it. We will start to write. How you will write? So first one, I'm going to start with the B1.
Okay, sir. It will
So
be
apply KVL. Okay.
R1 plus sorry, sir. R1 minus R2.
Wait a second. So while applying the KVL, so what is the B1?
28, sir.
28 volt. It is nothing but the voltage source, right? So directly I will write 28. Okay, na? And 28, if I'm considering 20 as a positive, then consider the R1. It is positive or negative?
It is negative, sir.
Positive.
Negative.
Negative, sir.
See, look at here. The B1 I'm going to consider minus to plus, and that one is positive, means here I'm going to travel from plus to minus. So the R1 become negative. Similarly, if I'm crossing from plus to minus, it will be negative. Otherwise, you can change for your current. 28 should be negative, means then this will become a positive.
Sir, அது உல்டா
Anything.
ஆயிடும், sir. Can put இந்த பக்கம் negative.
Voltage source I'm considering the positive and remaining as a negative. Minus. Now I'm going to write the voltage drop across R1, right? In KVL we written the voltage only, V1, V2, V3, likewise we written the voltage. Here the R is available and we don't know what is the voltage, and I is available. So what you are going to do, what you will do, any idea?
I find பண்ணணும், sir. V we have to find, sir.
Yeah, I we don't know. Okay, so I'm not going to identify. First one I'm going to write the equation. So here I1 I'm going to represent as it is, and R1 I'm going to multiply with I1. So I1 and R1, what is that? I1 into R1,
I1
it is nothing but V, right? So I'm
V.
going to represent the voltage across R1 in terms of the resistor R1 and the current I1. Okay, R1 and R1 is nothing but 4. So directly I will write 4 into I1. Likewise, have you got the point? So I'm going to multiply the 4 ohm resistor along with your current I1. So still current is, we don't know the current, so I'm simply representing the current parameter I1. Okay, and plus, sorry, minus
Yes, sir.
minus, I will mention in brackets so that you
2 I2.
4 into I1 to
I2.
I2
Sorry, I1, sir. I1, sir. 2 into I1.
Sir,
2
1
into
into
I1.
I1.
I1. Okay, and the problem is, look at that, there is a two node is available here also. The current will flow in this direction. Oh my god.
முதல்ல loop 1 கண்டுபிடிச்சிட்டு அப்புறம் loop 2.
Okay. Why? Because here also you have to represent the current I2. And I'm going to give a hint here. Hint in the sense, there are two possibilities are there. Suppose current is traveling in this direction. Okay, suppose current is traveling in this direction, in the sense the current I2. So consider this loop current as I2. Okay, if current is traveling in this direction, so that the I2 also will coming here, right? So here it is I1. I will represent, and here in this direction it is nothing but I2, which is generated from the second voltage source V2. Okay, so here the two current are combined together, so that if it is in direction, I will write the equation, one more equation, that is nothing but plus I2. So plus I2 will be common. This is the first case. Second case is that suppose if if okay, if the loop current is available in opposite direction in this manner, so the current will flow in this direction, I2, and again the current will flow here also, right? The rest is available, so the I2 will flow in opposite direction. On the time, what I will do in the sense, I will change the symbol. So previously both current are added together and coming in same direction, so I represent I1 plus I2. Suppose in second case the current is in opposite direction, means whether I want to make the variation, right? So on the time I will change the plus symbol into minus symbol with respect to loop 1, with respect to loop 1. So I'm considering I1 is in positive and I2 is coming in opposite direction, so I will consider I1 minus I2. So what about if you are writing the loop current with respect to I2, how you will write the equation? Just consider in this case there are two cases, possibilities are there. So in second case, how you will write? Now write the
Yeah.
loop equation. Can you try
That
the
will
loop
be
equation?
7,
7, sir.
7.
7 இது pick up போகுதுன்னா வந்து it will be minus
Sir,
or
minus
2
Okay.
7.
sir. That will be
2, 2, right?
oh yeah sir, it is 2. Yeah, okay sir. Minus
2
2 sir.
into
I2 sir.
I2 minus
I2, I2
Minus
Next
I1.
minus
minus
I1, minus I1,
yes,
I1,
sir.
yeah.
because my I1 is coming in opposite direction, and then again
1
minus
And then it will
1
be again minus
I2,
I2. Yes.
1 into I2. So this is how you have to write the equation. There are two cases with respect to. Suppose in previous case, if it is in positive, in the sense, what do you call it? The current is coming in opposite direction, in this direction, in the sense, on the time here this equation becomes I1 plus I2, it will come. And what about in this case?
அது எப்படி சார் நம்ம கண்டுபிடிக்கிறது எந்த
That
டைரக்ஷன்ல
We have to assume da நம்மளே நினைச்சுக்க வேண்டியதுதான் இது.
yeah, first case we have to assume, like I will write the equation like a positive here and plus minus and plus minus, and in this case I will consider the current is flowing from in this direction, you know, from the positive to negative the current will flow, right? The electron is moving in opposite, the current will flow from positive voltage to your negative. In some cases in the circuit diagram itself they will represent the current direction. On the time you have to write the equation according to the direction which they represent. Okay na?
Yes,
We
sir.
will see if you practice more problem, then you will get the clarity about it. It's just I'm telling first time, so still you may have a lot of confusion. Okay, okay, I will wind up the class. Time up. I will take the
Time
attendance.
ஆயிடுச்சு sir.
Yeah, I will take the attendance. Okay. Arnachalam posted. Yeah, I'm just checking the chat. Okay. Guys, I don't have your contact number. So if any issues, we can post in the group. Just add me in your group.
Sir, next yesterday itself we added you, sir. Ranjit add பண்ணியா இல்லையாடா?
It is available.
Not that. We have to.
ஆட் பண்ணிடுறா. அந்த கிளாஸ் முடிஞ்ச அப்புறம் ஆட் பண்ணிடு. அந்த group 2 மென்டார் இருக்குல்ல அந்த குரூப்லயே ஆட் பண்ணிடு.
Okay, answer
Hey,
attendance.
mental group. Yes, sir. Already you were added, sir. That
அதான் சார்
our
ஏற்கனவே ஆட்
vendor
பண்ணிட்டோம்
itself
சார்
added
நாங்க.
you. Vendor itself added you.
டேய் அது இவரா கிராபிக்ஸ் சாராடா? இவரா?
I don't think so. I'm not available in
சார் உங்க நம்பர் கொஞ்சம்
mechanical
சொல்லுங்க
group.
சார். வாட்ஸ்அப் நம்பர். Let me check sir you are there or not.
Yeah, I will post it.
Engineering graphics, sir. Sorry, sir.